This video will teach you how to do a spatial join 2 different ways. For this exercise, we've returned to the points layer of all the publicly available bathrooms in Australia, and we've added a polygon shape file, a polygon feature class, of the municipalities of Australia. So when thinking about conducting a spatial join, you have to decide which direction you're going to make the join. Would it be more useful to have the toilet points find out information about the municipality that they're in, or would it be useful for each municipality to know something about the toilets that it contains? Ultimately, we're going to do this both ways, but we're going to start by teaching the toilet points what town, what municipality they're in. Now, I have to tell you, I think the toilet points already know. If we open up their attribute table, they have an address, and the address has a town name. But some of those town names are different in the municipalities layer. This municipalities layer has like more details, like the Belconnen Town Center versus something else in Belconnen. When we do a spatial join, we don't care if we have a matching field. We don't need a join key anymore. It's not going to matter that these town names don't exactly match these town names, because a spatial join is done entirely based on location. What points are in what polygons, for example. Unlike a table join, we don't right-click to get a spatial join. Instead, we go to the Analysis ribbon and open the toolbox. And under Analysis Tools, Overlay, there is a tool called Spatial Join. Just like in a regular join, you have to decide which layer to put first. The layer you put first is basically what you're going to get out again. So the first time through this exercise, we will tell the points something about their municipalities. Therefore, we want to start with the points because points is what we're going to want to get out. So the first layer, the target features, will be the points, and the joined features will be the polygons. And this is a perfectly good name to save it under. For this example, our choices in this box are join one-to-one and join one-to-many. It's not going to matter for us because there is no toilet that would be associated with more than one municipality. So this is kind of a trivial choice here. We'll explore it better when we do the join the other direction. And keep all target features, sure. Skip the entire bottom half of this window, well, not all of it, but this big block, because this will matter when we go the other way. There is one more thing we need to check, though. Match option. This is how, spatially, how are we going to match a polygon with a point? I'll just pull this down so you can see all the choices. Intersect, within a distance, contains, completely contains, are identical to, boundary touches. There's a lot of choices. We're just going to use plain old intersect. If the point is on the polygon, pick up information about that polygon and add it to the attribute table. So now we run it. Okay. Takes a minute here. We get a new output. And it looks rather like the old output because it's points, but it has a bigger attribute table. Way out at the end of the attribute table, beyond all the stuff that was here before, we now have the information about the towns and the state. And so we could, if we wanted to, we could symbolize this. Well, let's just do it quickly. We'll symbolize this where every town's toilets get a different color. Let's do unique values by, and we'll use that town name too that was added on the end. Go ahead. This may not be all that attractive a symbology because it has so many. Oh, it's pretty. It's pretty, okay. And so now if we zoom in here, for example, we could see that, within this particular state, everybody got colored purple, and within this particular state, everybody got colored blue. So it's not that impressive, but it just shows you that the information is there. Oops. Oh, I guess we don't need to see the whole world. Let me zoom to this. All right, that's pretty. Now suppose, and I'm going to remove that. I'm going to go back to our plain old toilet points. Remove that. That's sort of the trivial way to do a join. The harder way is to go the other direction. To tell each municipality something about the points it contains. All right, so let's run the join for that. Let's go Analysis, Tools, Spatial Join. And this time what we want out is the municipalities. And we want them to have additional information about their toilets. And that's a perfectly good name to save it as. But now we need to talk about this one-to-one. If we chose one-to-many, here's what would happen. You'd have a municipality like this one that has 1, 2, 3, 4. I can't tell if that guy's really in here. Let's say 4 toilet points inside of itself. We could have an attribute table that has 4 copies of this polygon. One, the polygon gets matched with this one, the polygon gets matched with this one, etc. 4 copies. And somebody like this might have, 15 copies if it has a lot of points. Or, that's one option. It's not a great option for GIS because visually you only get 1 copy. We could join one-to-one. But then the question becomes, when we look at this municipality and it's got 4 points inside, which one is the one that we're joining one-to-one? If you don't do anything, if you don't make any decision, you will notice that the first one gets chosen. It's merge rule first. We could, however, have any merge rule we want here, and we can set different merge rules for the different fields. And that would allow those fields to be averaged, summed, or in some other way summarized so that you'd get out 1 polygon and it would have some sort of summary information about the points within it. So I'll show you the choices for merge rule. First, last, count, minimum, maximum, join. We're going to do count. We're going to have it for a field. I'm going to change the field to name 2, sorry. And use count. And the reason I'm using name 2 instead of name 0 I really don't want that one to say count. I'm going to let this one say first. And this one say name 0. If we take a field that is unique for every point and we count those unique names, we will get a column with a count that tells us how many points had been inside of it. The reason I didn't want to use name 0 is because name 0 is Australia, and the count will always be 1 because there's no different names. So if you get a name that is unique to each point, you can, for example, count it. And I'll show you what that looks like in the output table. If we had some numeric fields here, but we don't really. We could take, the average of the postcodes, or, yeah, there's not anything really useful in here. I think for now we'll make do with counting the names. We'll still use intersect as our match option and run it. Okay, now let's go look at the attribute table on this new layer that was generated. Okay, and what we get, in addition to a bunch of other stuff, which by the way is mostly meaningless now because it holds the first value. Unless we set the merge rule, it holds the first value it encountered. But the interesting column is this one, join count. It counts up how many toilet points had been in each municipality. And we could symbolize that new layer of municipalities by its count of toilets. I know that's not really very useful, but it's easy enough. So join counts, let's do quantile and 7 breaks. And maybe I should do something less red because it is hard to see here with all the red points. Let's just use shades of blue. Alright, that looks pretty nice.